Welcome to Fingerprints, an interactive data story about the hidden bias and how we discover new planets. For this project, given by Build for Good, uh, hosted by Tax, for the data visualization track, we chose NASA's Kepler Space Telescope dataset from the Exoplanet Archive. Kepler launched in 2009 and spent over 4 years staring at a single patch of sky, monitoring more than 150,000 stars. It was looking for one thing: tiny dips in brightness caused by planets crossing in front of their stars. This method is called transit photometry. So that's kind of what we were looking at here. And what ends up happening is Kepler confirmed over 2,700 planets, but flagged thousands more as candidates. And that transit method has a built-in bias. Planets that orbit fast and block more light are dramatically easier to deflect, and so or detect. Sorry. So there's a lot of bias here, and so what we're doing is also mapping that bias here. So this is our starting page. What you can see here is we have kind of the mission brief. We can launch the mission here, read it to say a story. We have some live term results, and when we launch the mission, we can see the catalog objects. So these are all the different planets that we have, or stars technically. We have mission insights. So 83 confirmed, 8 candidates, and 29 false positives so far. Kind of more information there. And then these are some of the high discovery picks. So we'll just start with this first one here. And so what we can see here is we have focus mode, cinematic mode. These kind of change it, and we can move in cinematic mode. We have the actual orbital phase that we can see here, and we can change that speed of the phase or slow it down depending on how you want to look at it. It tells you a little bit more information, like how it has a steady path, how it's only as 2 times as big as Earth, and it's hot like Venus or even hotter than that, and it gives more information. So then you can go here and explain the star, and this just gives you a little bit more information, like the field meaning guide, which tells you a little bit about what all these statistics mean and all these information. And then, we can also run an AI verdict. So this is what we mean with we're checking that bias. We're seeing if this is an actual confirmed planet, and why so, what type of bias there were, and stuff like that. And we can see here that it's basically around there, but it's confirmed, and there's a signal support or weak confidence. And that's just kind of some information about the star. We can open the star dossier. Let's just go back to where it was, and then what we can do is choose another star. So we'll just do this one here, and we can see this one's 5.5 times Earth size. It's a little bit different of phase, some different statistics, and a different AI interpretation story. And then finally, we can go back here to our explain this dataset story, and it kind of gives you the entire summary of what the data is and how we kind of went about it. So the entire thing is about the 9 years of staring at stars. It kind of gives that data story visualization of 150,000 stars, 2,700 confirmed planets, and 9 years of data. We give a lot of information about each type of data and visualize it, so we can see the Koi periods, durations, dispositions, stuff like that. And then, we have inbuilt biases, so we're trying to find it. And, this part here shows a good example of it. A Jupiter-sized planet blocking 1% of the starlight produces a signal that's 100 times stronger than Earth. So it's very skewed towards those big hot planets versus something like Earth, which is not as common, and these are the easiest to find. So we get a little bit more details and visualizations. So how are these signals actually classified? So what are these different things? What is the actual bias pattern that you'll see here? And then we can try it ourselves. So if we produce a transit dip like this and analyze it, we can see we produce a Neptune class with around 17,000 ppm and stuff like that. And then we can go do another one. We'll do something like that. And we get another Neptune class, but this one's a 9.9 times. If we go something like this, also Neptune class, and then let's just do some small one here, mini Neptune. So these are the different things. And then finally, habitable zones. So we can see here that we have one that's actually habitable where we can stay, and we can kind of mess around with the temperatures, the star radius, stuff like that, to find out how many of these actual stars could we stay in if they were in that specific temperature. And altogether, this kind of just gives our summation of our entire project. It was built using React, Vite, 3JS for the 3D, D3 for data visualization, TensorFlow for ML interface, and Canvas for the actual drawing information. And it kind of tells you just out there, we have a random sample of things, and we're trying to visualize this entire huge observations of all these planets. And I think that's just really cool.